and mass transfer. Zeroth law of thermodynamics about thermal equilibrium related to thermometer. First law of thermodynamics, energy conservation. Second law of thermodynamics, heat transfer. Modes of heat transfer: conduction, delta T due to molecular lattice vibration energy transfer and also by free electron transfer. K silver is equal to 410 watt per meter Kelvin, K copper is equal to 385 watt per meter Kelvin, K aluminum is equal to 100 watt per meter Kelvin, K steel is equal to 17 to 45 watt per meter Kelvin. K pure metals greater than K alloys. K asbestos 0.2 watt per meter Kelvin. K glass wool 0.075 watt per meter Kelvin. K refractory brick 0.9 watt. K polymethane foam 0.02 watt per meter Kelvin. K diamond 2300 watt per meter Kelvin non-metal. K water 0.60 watt per meter Kelvin. K mercury 8.43 watt per meter Kelvin. Convection delta T due to macroscopic bulk motion of fluid. There are two types: natural convection, forced convection. Radiation, electromagnetic wave propagation with a speed of light. Body at 0 Kelvin minus 273 degrees centigrade does not emit radiation. Fourier's law of conduction, Qx is equal to minus Ka dt by dx watt. Newton's law of cooling, Q convection is equal to Ha Tw minus T infinity watt per meter square. For forced heat transfer, H is function of F of V bar d g rho Cp mu K. For natural heat transfer, H is equal to F of G beta delta T L mu rho Cp K. Free convection in gases, H is equal to 3 to 25. Free convection in liquids, H is equal to 250 to 600. In liquids it is more. Forced convection in gases, H is equal to 25 to 400. Free convection in maybe it is forced convection in liquids, H is equal to 600 to 4000 watt per meter square Kelvin. Stephen Boltzmann law of radiation, EB is equal to sigma T power 4 watt per meter square. Sigma is equal to 5.67 into 10 power minus 8 watt per meter square Kelvin power 4. Conductive thermal radial resistance, RTH is equal to L by Ka. Convective thermal resistance, RTH is equal to 1 by Ha. Overall heat transfer coefficient, 1 by U is equal to 1 by H1 plus L1 by K1 plus L2 by K2 plus 1 by H2. If U value is more than heat transfer rate will be more. If U is more, then heat transfer rate will be more. Radial convective heat transfer to Halo cylinder, Q is equal to 2 pi KL T1 minus T2 by ln of R2 by R1. Critical radius of insulation, R is equal to K by H for cylinder, R is equal to 2K by H for sphere. Resistance in slab, RTH is equal to B by K. In cylinder, RTH is equal to ln R2 by R1 by 2 pi KL. In sphere, RTH is equal to R2 minus R1 by 4 pi K R1 R2. Generalized heat conduction equation, dou square T by dou x square plus dou square T by dou y square plus dou square T by dou z square plus Q dot by K is equal to rho Cp by K dou T by dou tau. Thermal diffusivity, alpha is equal to K by rho Cp. Laplace equation, delta square T is equal to 0. Dou square T by dou x square plus dou square T by dou y square plus dou square T by dou z square equal to 0. Heat generation in slab, T is equal to minus Q dot by K x square by 2 plus C1x plus C2. Generalized heat conduction equation in cylinder, dou square T by dou R square plus 1 by R dou T by dou R plus 1 by R square dou square T by dou pi square plus dou square T by dou Z square plus Q by K is equal to 1 by alpha dou T by dou tau. Heat generation in a cylinder, T is equal to minus Q dot R square by 4K plus C1 log R plus C2. T minus T naught by T minus TW is equal to small r by capital R whole square. Maximum temperature, T max is equal to Q dot R by 4K plus Q dot R by 2H plus T infinity. For infinitely long fin, t minus t infinity by t naught minus t infinity is equal to e power minus mx. Q fin is equal to root hp ka t naught minus t infinity watt. Fin is finite in length, but its tip is insulated. M is equal to root hp by ka. T minus t infinity by t naught minus t infinity is equal to cos hm into l minus x by cos hml. Q fin is equal to root hp ka into t minus t infinity tan into tan hml watt. Fin is finite in length, but its tip is uninsulated. Then t minus t infinity by t naught minus t infinity is equal to cos hm into lc minus x by cos hmlc. Q dot is equal to root hp ka t naught minus t infinity into tan hmlc. Lc is equal to l plus t by 2 for rectangular fin. Lc is equal to l plus d by 4 for pin fin. Fin efficiency eta fin case 2, which means fin is finite length and but its tip is insulated. Then it case to tan hml by ml. Eta fin case 3, that is uninsulated, tan hmlc by mlc. Fin effectiveness is equal to Q with fin by Q without fin. Unsteady or transient conduction heat transfer Ti minus T infinity by T minus T infinity is equal to e power Ha by rho v Cp tau. V by a sphere is equal to 4 by 3 pi r cube by 4 pi r square is equal to r by 3. Lumped heat capacity analysis, Biot number is equal to S by Ka by 1 by Ha. If internal conductive resistance is equal to external convective resistance, then Hessler chart is used. Heat exchanger. Heat exchanger is a adiabatic steady flow open system in which flowing fluid exchange heat. Example: steam condenser, economizer, superheater, air preheater. mh dot cph into Thi minus Thi is equal to mc dot cpc into Tce minus Tci. Delta S universe is greater than delta S universe parallel flow heat exchanger greater than delta S universe counter flow heat exchanger. Mean temperature difference delta Tm is equal to 1 by a integral inlet to exit delta T dA. Parallel flow T delta Ti is equal to Thi minus Thi. Delta T is equal to Tce minus Tci. Delta Tm LMTD is equal to delta Ti minus delta Ti by ln of delta Ti by delta T. dq is equal to mc dot cpc into Tce minus Tci is equal to mh dot cph into Thi minus Thi. Counter flow delta Ti is equal to Thi minus Tc by Tc. Delta T is equal to Thi minus Tci. Delta Tm is equal to delta Ti minus delta T by ln of delta T by delta T. Delta Ti by delta T. dq is equal to minus m dot h cph Thi minus Thi is equal to minus mc dot cpc into Tce minus Tca. Q is equal to UA LMTD. Delta Tm is more A less value in counterflow because LMTD is more in counterflow. Delta Tm counter greater than delta Tm cross greater than delta Tm parallel. When a fluid undergoes phase change, delta Tm parallel is equal to delta Tm counter. Case 2, when both fluids have equal capacity rates, delta Tm is equal to either delta Ti or delta Te. LMTD methods: mh dot cph into Thi minus Thi is equal to mc dot cpc into Tce minus Tci. LMTD is equal to delta Ti minus delta Te by ln of delta Ti by delta Te. Q is equal to mc dot cpc into Tc minus Tci is equal to mh dot cph into Thi minus Thi. A is equal to Q by U delta Tm is equal to dash meter square. Another method, NTU method. Capacity ratio C is equal to m dot cp smaller by m dot cp big. NTU is equal to UA by m dot cp small. epsilon effectiveness of heat exchanger is equal to THA minus THE by THI minus TCI if m dot Cp is small, or TCI minus TCI by THI minus TCI if m dot MC dot CPC is small. Whichever is smaller, that will be on top. Effectiveness of parallel flow heat exchanger epsilon is equal to 1 minus e power of minus of 1 plus c into NTU by 1 plus c. Counter flow heat exchanger epsilon is equal to 1 minus e power of 1 minus of 1 minus c into NTU by 1 minus c into e power minus of 1 minus c into NTU. If c is equal to 0, epsilon p is equal to epsilon c is equal to 1 minus c power of minus NTU. If c is equal to 1, epsilon p is equal to 1 minus e power of minus 2 NTU by 2. Epsilon c is equal to 0 by 0 undefined. So there is another formula, epsilon c is equal to NTU by 1 plus NTU. Radiation total emissivity epsilon is equal to emissivity of body by emissivity of black body. Kirchhoff's law of thermal radiation epsilon is equal to alpha. Kirchhoff's law. Planck's law of thermal radiation EB lambda is equal to 2 pi C1 by lambda power 5 into E power C2 by lambda T minus 1 watt per meter square micrometer. Wien's displacement law lambda mt is equal to C is equal to 2898 micrometer Kelvin. Stephen Boltzmann law EB is equal to sigma T power 4 watt per meter square. Lambert's cosine law I is equal to I n cos theta. Intensity of radiation I is equal to dE by dW watt per meter square steradian. Diffuse surface EB is equal to I pi watt per meter square. Shape factor 0 less than or equal to Fmn less than or equal to 1. Reciprocatory relation between shape factors A1 F12 is equal to A2 F21. Summation rule among shape factors Fn11 plus Fn2 plus Fn3 so on Fnn equal to 1. Radiation heat exchange between two infinitely large parallel plate Q by is equal to sigma T1 power 4 minus T2 power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1 watt per meter square. Radiation heat exchange between two concentric infinitely long cylindrical surfaces Q is equal to sigma into T1 power 4 minus T2 power 4 by 1 by epsilon 1 plus A1 by A2 into 1 by epsilon 2 minus 1 watt. A1 by A2 is equal to 2 pi R1L by 2 pi R2L is equal to R1 by R2. A very small body in a very large enclosure Q is equal to sigma into T1 power 4 minus T2 power 4 into A1 E1 watt. To get error in temperature measurement of gases by using thermocouple Tg minus Tc. Radiation networks irradiation G is equal to J minus epsilon EB by 1 minus epsilon. Radiosity J is equal to epsilon EB plus 1 minus epsilon G. Heat exchanger Q is equal to EB minus J by 1 minus epsilon by epsilon A. Q12 is equal to J1 minus J2 by 1 by A1 F12. For infinitely large parallel plates, Q by A is equal to sigma into T1 power 4 minus T2 power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1 watt per meter square. For infinitely large concentric cylindrical surfaces, Q12 is equal to sigma into T1 power 4 minus T2 power 4 into A1 by 1 by epsilon 1 plus A1 by A2 into 1 by epsilon 2 minus 1 watt. Radiation shields Q12 is equal to sigma into T1 power 4 minus T2 power 4 by 1 by epsilon 1 plus 1 by epsilon 2 plus 2 by epsilon 3 minus 2 watt per meter square. If epsilon 1 is equal to epsilon 2 is equal to epsilon 3 is equal to epsilon, then Q by A net is equal to with n shields is equal to 1 by n plus 1 into Q by A without shield. Convection Q is equal to HA delta T. H is equal to F of V bar D rho mu Cp K. Thermophysical properties. V bar velocity of fluid, D characteristic dimension of body. Reynolds number Re is equal to Vd rho by mu is equal to If by Vf. If Re less than 2000 laminar flow, if Re greater than 4000 turbulent flow. Nusselt number Nu is equal to Hd by K. Prandtl number Pr is equal to mu Cp by K. Cp joule per kg Kelvin, K watt per meter Kelvin. Hydrodynamic boundary layer velocity distribution U by V infinity is equal to 3 by 2 into Y by delta minus half Y by delta whole cube, where delta is equal to 4.64 x by root REX or 5x by root REX. Delta directly proportional to root x, delta directly proportional to root mu, tau inversely proportional to root x, hx inversely proportional to root x. Local convective heat transfer coefficient Hx is equal to minus kf dou T by dou y by Tw minus T infinity. Momentum equation of HBl mu u dou u by dou x plus v dou u by dou y is equal to minus of dou square u by dou y square. Energy equation of thermal boundary layer U dou T by dou x plus V dou T by dou y is equal to alpha dou square T by dou y square. For any given fluid, delta T by delta is equal to 1 by 1.026 PR into PR whole power minus 1 by 3. Average convective heat transfer H bar is equal to 2H. Nusselt number Nu bar is equal to H bar L by K is equal to 0.66 for RA power half PR power 1 by 3. Stanton number St is equal to Hx by rho V infinity Cp. Reynolds Kolbum analogy Stx PR power 2 by 3 is equal to Cfx by 2. Forced convection through pipes heat transfer is Q is equal to m dot Cp TB exit minus TB inlet. Bulk mean temperature TB is equal to 2 integral 0 to capital RUT dr by R square V mean. Constant heat flux dq is equal to hx delta t, nu is equal to hx d by k is equal to constant 4.36 is equal to 4.36. Constant pipe wall temperature if tw is equal to c, dq decreases, nu is equal to hx d by k is equal to 3.66. Delta t is equal to tw minus tb. If dq is equal to constant, tw increases. McAdams or Dittus Boelter equation. Nu is equal to 0.023 Re power 0.8 PR power n is equal to 0.4 heating of fluid, n is equal to 0.3 cooling of fluid. Natural convection H is equal to function of G beta delta T L, mu, rho, Cp, K. If beta is more, stronger buoyancy forces. Grashof number Gr is equal to inertia forces into buoyancy forces by viscous forces whole square. Inertia force into buoyancy force by viscous force square. Gr is equal to G beta delta T L cube by mu square. Nusselt number Nu is equal to HL by K. Prandtl number PR is equal to mu Cp by K. Nu is equal to C into GR PR whole power M. M is equal to 1 by 4 laminar flow. M is equal to 1 by 3 for turbulent flow. GR PR less than 10 power 9 less than 10 power 9 laminar free convection. GR PR greater than 10 power 9 turbulent free convection. Beta is equal to 1 by Tw plus T 1 by Tw plus T infinity by 2.